Okay, all right, ladies and gentlemen. Okay, so allow me to share my screen. Okay, so ladies and gentlemen, what you can see from here, this is about the operation management in managing project. So today's here, I will share with you about how a project can be managed here. Right. Okay, so what you can see from here is about the operational management. We're looking specifically in handling of projects here. So in handling projects here, we have several learning objectives here that to be covered. Okay, so starting from the learning objective of our essential procedures in the project management, we have on the goals about the methods or the tools that we are using in the scheduling. Okay, for example, here we can using about Gantt chart. So the Gantt chart itself be able to record and provide the scheduling accordingly. Thirdly, we able to have the development of project management techniques. Okay, specifically in this itself, we were looking for PERT analysis and CPM analysis. So PERT and CPM becomes the analysis we are trying to looking for, the projects that can be managed in a way. Okay. So beyond that here, we also have the apply the threat of and the project crashing. Project crashing is one of the quite important area, and that area will be available to provide you with a better, more critical of decision makings in providing about a certain project activity here can be arranged or can be shortened here. So therefore, I'm providing you further about how on these learning objectives here that can be delivered. Okay. So for your understandings here, I will also provide the discussion is start from the characteristics for the project. Okay, so a project itself usually is about the stand-alone project. Okay, the stand-alone project in the sense that the project is more towards have their own set of activity. And every project, whatever the project we are ongoing here, the project will comes together with their own expected time, for instance. Okay, so by looking on the beginning for the project start and the end for the project start, it will have their own rules to be followed here. Okay, so including here numbers of rules here, I will try to guide you further on how that can be managed in here. Okay, right. So ladies and gentlemen, also providing you about numbers of the activities here will be arranged in a project. So later on, I'll show you one of the examples we have under this project here. Okay, so under platform manufacturing, they will providing about how the arrangement of this set of the projects here. So that will give you a quite easier understanding on how you're supposed to do. Okay, so with the high level of skill and the frameworks that we have, then we have numbers of other resources to be considered in the beginning of the project until the end of the projects. So in the characteristic of a project, as I mentioned, we are trying to have our main goal in order to know what is the project outcome we are expecting. Therefore, we work on that further here on what we're supposed to do. Okay, so example for the projects here, ladies and gentlemen, is including, we can say that the project of rocket sciences, okay, we try to have the formulas, right, in order to have the sciences experiments, that also considered as a project. Now, beyond than that, I would say the normals of the projects here is all you understand about is about the construction project. Okay? Project can be soft, project can be in a tangible project and also can be tangible. For example, it's given a project here for you to come up with a programming. Okay, so a new set of programming here that demanded by the client. Okay, so this programming project is also can consider as one of the examples here. Okay, so nevertheless, I would say, so in terms of the project itself, we have tangible projects, okay, such a building of a high-rise building, okay, including building bridge, building condominiums, buildings, the relevance of stadiums, all of this here can be considered as a project here for construction. But of course, nevertheless, here, show you further about how we manage about the projects here. Okay, so you can see in the beginnings here, for managing a project, we always come from the planning. So planning itself is quite important here, given you about the understanding. Okay, so I think I can try to provide this will be easier. Okay, easier in the Okay, so what you can see here basically is about the planning. So the planning part here is about we try to plan resources, we try to set the goal for the projects here on what is the objective we try to achieve in the end. We identify the resources. Resources can be tangible, can be intangibles. Okay, so that will be relevant from one project into another project difference. Now, on top of that here, we also have the work breakdowns. Okay, some numbers of works here might be required to have their own specific of step by step to be followed. Okay, so this work breakdowns here, this can be one of the area we can involve, and we do need the support, especially for the team member. Okay, so the organization, they do have the managers, the employees, the workers, that all of them here can be determined in terms of our earlier planning stage. So this earlier planning stage here, we have conceptualized about the project before it starts. We do have a proper planning so that when the project is ongoing here, we are fine. We be able to perform this accordingly. Okay, further on from this here, we do have the scheduling. Okay, so scheduling for information here, that does cover about the project activities. Okay, so scheduling about the activities here, including we try to arrange those activities. Okay, so numbers of activity I will show you with example later. That regarding what activities here we can make it start earlier, and what activity here we can make it start parallelly. Okay, so parallelly means that we start at the same time. Okay. So that also can consider we have parallel activity to be in a project here. Okay, for examples here, you can provide a project, I mean, in a layman understanding. Okay, if yourselves here are doing reports currently, so at the same time, you also can have your download or the streamings of whatever the video or activities here we can put on one side here. So to do your project at the same time. So the parallel activities here is more towards to say we identify those activities that can be executed at the same time. So that is what we need by the parallel project arrangement and activities here. Okay, so no doubt here in the scheduling part here, we do have the start and end activities. So for each of the activities here, they do have the time. Okay, so the timings here, once the moment we arrange that on schedule, it will see the things differently. Okay, so this, when we are catered for numbers of the project itself here, that will be in a network. Okay, and that entire networks here, we will going through about the network as the relation in between one or another activities here, from the start of the activity until the end of the activities here. So that's what we have under this scheduling. Okay, so beyond that here, we do have another part, it's called controlling. Okay, in any of the management of the projects here, definitely importantly, we do have need to manage our resources. Okay, so we try to manage including the fees for the projects here. So we try to have the fee which is not above our budget. Okay, so based on the constraint of the resources, I do understand there is a need here for us to set the resources. Otherwise here, the companies here definitely will have such of the difficulties and suffering from the waste. Okay, so that makes about some corrective action or changing of the plans might require to make the resources are more useful until the maximum. So that's why we have this control comes to the picture. So what I'm providing to you is such a, see, if you're looking for the controlling, by right, the controlling is not the end on it. Okay, so we are saying that once the controlling is all done, it will go back to the planning stage. Okay, so when planning stage itself here, that is about the next cycle of the planning. So this will be a circles in the pictures to say planning start first, going for scheduling. After scheduling will be on controlling, and controlling will be provide feedback on the next planning here. So therefore, this is one of the cycle that we're having here in order to have the project ongoing, to have reducing the project errors and whatsoever the problem might happen in the next or the futures here. So therefore, in this management of the project itself, we are quite constant in order to have all of this here should be in place in the beginning. Okay, right. So ladies and gentlemen, we have our project planning for you. Now, project planning here is more toward, I think, so you can need to see the pictures here. Okay, so the picture saying that we have to identify what are the activities here is start first, then second activity going for second, and continuous to other activities. Okay, so this is about the series of activity is related to each and another. Okay, so in the project planning itself, I would say we are trying to identify those important activity or tasks here to be connected from one into another. This means also providing you with the numbers of interrelationship of the activity to be identified. Okay, so from this project planning itself here, it's also given you for the other activity involved. Okay, as such here, looking for the objective, we try to establish, define the projects here, right? So try to identify the works and the sub-components for the works here, as we understand from the work breakdown structure. Determine the resources, as I mentioned, tangible and intangible resources required for this planning of the project. And lastly, we are looking for the team member or the structure of organization in supporting for the project planning here. Okay, so of course, this forming of the organization example, we can be looking for people who are work within the firm or the people who are the expert that we can gain resources from outside of the firm. For example, expert consultants that from outside from the firm be able to provide the understanding for this project planning here. Okay, so this can be one of the good things here we have for the formation. Okay, so nevertheless here for the project organization, okay, project organization always come towards the pictures for you that these projects here somehow is temporary. Okay, so temporary means that once the project is completed, so the entire team or the structures here, it can be demolished. So in the ways that we can be replaced or the structure are no longer exist anymore. Okay, so that can be the temporary structure. Other than that, here project organization also come with a specialization for the entire company. So when this comes for the entire, the specialization for the entire companies here is giving you the understanding that the project can be variants or it can be specialized in one into another. So specific group of the activities here we can cater as project organization. Okay, right. So other than that here, usually a project itself here, it will be headed by project manager. So the people who are responsible and in charge for the project, we usually call it as PM, project manager. Okay, so the project manager try to determine resources, try to coordinate the activities, right? Determine about the arrangement, scheduling, costs, monitoring. It's all done by the project managers here. So project manager, in a sense that they are trying to provide all the activity relate to manage the project entirely. Okay, so this is about the heading and be championed by the project manager. Now, beside that, we do have the others is called for permanent structure of matrix organization. Now, for your understanding, matrix organization is referring to two departments that collaborate for the same task. Okay, why do I say so? Now, if you're looking for matrix structure in some of the organization, they do have the departments of productions and they do have the departments of function. Function means, for example, like human resource departments here, or we have the functions for accounting departments here. Okay, so when two departments are joined together, so these two departments itself here, they by right having their own superior, their own boss here. So the own boss itself here are trying to have the pool of discussion between the two organizations here, between the two departments here. So in that situation, I would say a matrix organization usually it will come with advantage and disadvantage here. For example, advantage is now we can say these two organizations or two departments that are joined together, it will have a great resources. Okay, so in terms of manpower, in terms of resources, tangible, intangible, it will be there. So it's definitely with huge resources can be shared. Okay, so that's one of the good things under the advantage of this matrix structure. But the disadvantage under this matrix structure, it should also include the argument, conflicts, okay, even though for the quarrel in between the two departments here, because especially when the superior are not coordinate the works nicely. Okay, so therefore the potential of the quarrels, it does happen to reflect the company and the coordination of work become difficult. Okay, so there will be the matrix structure or the matrix organization we mentioned here to have pro and also cons. Okay, so that will be the availables of the cons and pros for you here for the matrix structure. Okay, a simple project. So ladies and gentlemen, so you can see quite clearly based on this chart. So what you can see from here, it will be the presidents. Okay, so president is belong to the top management. Okay, so this president will having the final say. So to provide the direction for the company, so and provide whatever the etc. Important decision making for the company. So, okay, so president himself here, they will underneath here we have human resource, we have marketing, we have finance, we have design, we have quality management, right? We have production. So all this here we can say is the different department itself. Okay, so what I'm trying to bring to you here is now if you're looking for a project one. Okay, so the first project itself here, we do have the engineer from design department. We do have the quality management engineer. We do have the production engineer, technician from the productions here. So when these 1, 2, and 3 people here, I mean, they are trying to collaborate and they try to contribute to a project under a project manager. In that situation is what we call the structure. Okay, so the organizational structures here, right? So further on here, given you another understanding, so like project manager 2, right? So project manager 2, they will have a different of the engineer. Same thing from the design, but can you see that? Electrical engineer are different from mechanical engineer. So because of the project, this one and the project 2 here, they are different. So the require person will also have difference here. But nevertheless, what we are saying about the project organization to say, we have the project 1, we have the project 2. These 2 projects here is also under the president, under one company here. So in that situation, this is what we call project organization. Okay. Right. So right after this here, we have project scheduling. Okay. Now project scheduling, ladies and gentlemen, for you in this project scheduling, what we need to identify here first and foremost is a precedence relationship. Okay. Precedent relationship means we are trying to have the interrelationship between variables. Okay, I mean variable means that between the activities here. Okay, a very simple question. Okay, I ask you first. Now, in terms of construction on land, okay, perhaps you can see these pictures here. Okay, construction on land, we'll say we are supposed to do the piling first, or we supposed to build the rooftop first. Okay, which one do you think? Okay, we should have the piling first or the rooftop first. Okay, so quite obviously, based on the example I provide here, any of the construction, for example, like whatever in the pictures here, we do have the piling first. Okay, so the piling that you can see, this is the piling here. Okay, so the piling here is emphasizing is on the building to support based on the land base. Now, once the piling is ready, okay, then only we be eligible to build the rooftop. Okay, so obviously, in identify the precedence of relationship, we must know which activity comes first, which activity comes second. Okay, so that makes you about the idea on how the relationship between the activity works. Okay, so that is come for the second point here. Now, second point over here, we are saying that the sequencing of the activity, which one comes first, how many times you need for the activities. And only we go for the next activities here. So that's why we have this sequencing activities here from one into another. There are difference here. Other than that, ladies and gentlemen, we have the determining activities of the kind and cost here. So I would say all activities here definitely with time. Definitely we need some allocation of budget or expenses to that activity itself. Okay. So of course, on top of that here, the fourth one, we do have the materials and also the worker requirement. So the material and worker requirements here, it will give you the understanding that, okay, by right, this project scheduling might require us to know there is a substantial and a sufficient of material required for this here. And eventually, the last one here, we try to looking for the critical activities. Now, critical activity means that the activity is very important. Okay, so the activity, as I mentioned, the activity will determine the final project duration. Okay, so the delay for those critical activities, it will delay the project. Same things here. If we try to make the earlier part the earlier for the project to be complete, we also will deal with the critical activities here. So this is what we are understands from the project scheduling here. Okay, right. So moving forward here, we do have the purpose for the project scheduling. So what I'm presenting to you here, this is about the relationship. Okay, so first point, okay, quite clearly. Our first point mentioned that, okay, the relationship between the activity we must know. Okay, so in any projects here, regardless your project for construction, your project from biotech, your project from accounting, your project from uh, building a cars, okay, or any of the science rockets projects here, obviously, you must know all the activities that belong to that relationship. And this should be showing quite clearly in the pictures. Okay, later on, I will share with you on a project based on the examples here. Now, second is here, you also can see numbers of this precedence relationship. As I mentioned, the relationship for the activities, which activity comes first, which activity comes second, and so whatsoever etc. notes here. So A only go for B, B will go for C. So A, B to C. That is about the precedence relationship we are talking about here. Okay. So realistically, we also mentioned about the relationship among the activities here that need to be known. Okay. So therefore, when arranging the activities here, it sounds possible. Thirdly, you can look for the activities here. Okay, the activity itself here definitely is come with the timing and also the cost. Okay, so eventually some situation, the timing it might be have a variance. Okay, for example here, activity of cooking. Okay, so if you're looking for in terms of cooking a steak, okay, so cooking a steak, people might say that in terms of 60 seconds, okay, in terms of 120 seconds, or even though in terms of the variance. Okay, so the time that your cooking will be have a variance here. So that is what we are needed about the estimation. Okay, so we try to estimate the time, estimate the cost for each of our activity, so that this can be encouraged, will be available for our projects here. Okay, so beyond that here, we do have this. It's better for us to utilize the resources here. Okay, we have people, technologies, monies, materials, resources, right? Any of the activities here to manage in a project. Okay, so in the project itself here, we do have those activities which is bottleneck. You see that? Critical bottleneck. Okay, bottleneck means those activities are very important. Okay, as also another synonym for critical activities here. Okay, so if you delay those critical activity duration, it will delay the entire project. At the same time, if we try to shorten the duration for the project, we usually also try to deal with the critical bottleneck activities. For examples, we try to shorten the duration for the bottleneck activities here. So that is possible for the project durations here. Okay, so I hope that you're getting these meanings. Okay, beyond that here we have project control. Okay, so ladies and gentlemen, as you can see for this project control, it's about the control for the management system. Okay, so we have numbers of control for a project we will take place, including the project in terms of resources. We can control in terms of the quality, right? In terms of the monitoring for the quality, we will come through stage by stage. Okay, so for example, in the construction for the building, okay, so in a high-rise condominium, for example, right? So the construction itself here, it will check the quality every phase they have done. Okay, so meaning to say, when the piling is done, the checking of quality will be there. The inspector will be there. So they are trying to ensure the qualities here and the budgets here are trying to fit here for any of the project control to be online. Okay, so another understanding to say the project controls here, you also can consider that to be okay. So the consideration for the project control, it can be in terms of the quality that measuring by a standard or specific of software here. Okay, so some software here will be able to check the results and the response. Okay, can be provide the result immediately. So that is one of the good things here. We use some tools in order to assess the qualities here. Now beyond that, in somehow, when the moment we're going to check about this project control, we will require to revise a project. Okay, so for example, here, so if you are checking about based on the scheduling for your project, some certain steps or certain approach here. So we can see that based on the project itself, by right, they're supposed to finish the project in 4 days. Okay, for example, right? So the project itself here is somehow until the 5th days is yet to complete. Okay, so that situations here as a project manager, usually they will try to control and try to see what is really happening for the projects here. So are they required to add more manpower for the projects? Are they required to have some adjustment for the project activities here? So they will try to check what is going on with the project itself. So that's why we need here to have some adjustment towards the project controlling. Okay, right. So beyond that here, ladies and gentlemen, you can look for the project management techniques here. Okay, so what we can see over here will be the Gantt chart. Okay, so Gantt chart is one of it. Okay, second here is CPM, critical path method. Thirdly will be the PERT analysis. Okay, program evaluation and review technique. Okay, so this is the 1, 2, and 3 methods we are going to display to you today. So CPM and the PERT analysis, you can say that this is one of the techniques is happened in 1950s. Okay, based on this technique itself, initially is employed in the chemical plant. Okay, because we need the chemical plant. There's so many activities that happens here. We try to ensure the activities here are in line. Okay, so we are trying to identify the precedence of the activity, meaning to say which activity comes first, which activity comes second, which activity comes first, or any other activity relationship we try to identify. Now, one of the activities here that's involved in here that we are trying to estimate the time for the activity, because in the chemical plant itself is very crucial. Time is money. So we are trying to estimating all of this here in the expected time to complete all of the finishing products. Okay, so what I bring to you here for your attention is about the 6 step in PERT analysis and CPM. So ladies and gentlemen, so I'm going for step by step. Step number 1. Okay, so you can say step number 1 here is more toward the project that we need to prepare all the breakdown. Okay, so the breakdown to say that we might looking into the activities for the project itself. Okay, so I will provide the example for you about what is meant by the breakdown. Okay, so one into another here. Now, once we have completed about the first step, second step, we will go for the relationship. Okay, so the relationship we are talking about here is try to identify the activity itself. Okay, so in between activity A, activity B, activity F, for example, here. So which activity should come first? Is it A come first? Is it B come first? Is it F come first? Okay, so which activity that will be following the orders here. Okay, I will show you by example about how is this can be followed by orders. Okay, now, ladies and gentlemen, again, we have need to draw the network. Okay, so when drawing the network itself, I would say this is network that connect all the activities as what we have developed in the step number 2. Okay, because in the step number 2 here, we have identified all the activities here that need to be following the order. Okay, so therefore, once we know about the relations in between the activities, we be able to connect and be able to link the activity in a diagram. Okay, that is what we call we draw the network here. I will show you by example shortly. Okay, so once we have complete about the step, we have 4 steps to go. Okay, 4 steps to go is try to estimate the time and also the cost. Okay, so each activity is definitely if we have a certain time to complete, to be complete by the times here. Okay, for example, in terms of the time for the activity A, it might have 2 weeks. Activity B, it might have 4 weeks. Activity C, it might have 6 weeks. Okay, so the time is out here that will be eligible and providing for you. Second is here, the activities in terms of cost is also required to be included. Okay, so this is one of the steps here in step number 4 here. We are looking forward to getting the cost activities for itself and also the time. Now, after that here, we can have activity 5 here. So activity 5 here is about how we are identified the network. Okay, we can compute the longest network. We try to identify the critical activities in the network. Therefore, we co-join all the critical activities out. That is about the critical path. Okay, ladies and gentlemen, here this part here will be the critical path that is going through all the networks here. So hence, this is one of the critical path here we're looking forward in your network draw. Okay, right. So of course, I was looking for that here. Once we have knowing about the critical path, what is next? The next thing here is we monitor, we schedule, we control the project, we also have whatever needs that is required to have a better network here. Okay, so as I mentioned just now, if you see carefully, if in terms of makes the project to be finished earlier, okay, in a sense that we try to have the project to be complete before the time. That is also the project crashing we try to go for. Okay, so in this number 6 itself here, project crashing can be happening here. Okay, right. So of course, for your understanding, among all the 6 steps, which is most important is the number 5. Okay, because step number 5 here is giving you the understanding throughout the networks here. We call it as a critical path. And this critical path here is giving you very important information to knowing that the longest part that in the project. So it's very important that you should know what is meant by the longest time path through the network. Okay, we'll show you by examples here. Okay, right. So always here there will be a question to be asked here for the CPM and the analysis here. So all this here can be answerable. Okay, answerable to say now by the end of our analysis, we'll be able to know when is the project can be completed. Okay, so exactly we know how many days, how many time, how many days, how many weeks, how many months that project here can be completed. Okay, regardless any project, okay, software project, rocket science project, building a car project, right, construction project, all that can be done here. Shouldn't have any problems. Okay, second is here, we're also knowing about the critical activities through the critical path of the network. Okay, so based on this network itself, we also able to identify, I would say, the activities that relevantly to know about what is the longest time path throughout the network. So we will be able to know that. At the same time, if you be able to identify the critical activities, you also will know the non-critical activities here. Okay, so therefore, based on the non-critical activities, it will be more sounds like the activity it seems like not important, but it is in the path. Okay, so sometimes here we do have that happen in the activities throughout your network path here. Okay, so last but not least here, we also be able to have probability, okay, to know about the variance or the deviation of your project to be complete in a certain time, and not if we have a certain variance, plus minus of the certain days here that can be completed in a specific time as required. Okay, so this is about the PERT and the CPM here. By what they'll be able to answer your question accordingly here. Okay, so moving forward here, we do have the number 5 here that the CPM and PERT analysis be able to answer, including we do know about the project schedule, whether there is on time, before the time, or after. Okay, so that all answer can be provided here based on the PERT analysis. Okay, so we also might knowing about our budget in terms of the cost for the activities here. So are we spending our money, okay, so equally to whatever we have project? Okay, so or we are spending the money is lesser, or we're spending the money is more. Okay, so that can be in our discussion to be included in the CPM and PERT analysis. Ladies and gentlemen, beyond that here, I would say that it will be also looking for the resources. Okay, so the resources that whether there is sufficient or there is additional resources you may require in order to add on to the project here. So that's why we might need this to be available and we answer, okay, through our analysis for PERT and CPM. And last but not least here, we also be able to possible to know that if a certain time, for example, 15 weeks for a project, we'll be able to shorten it into a certain duration. That also can be answerable by PERT and CPM analysis. So that's why this technique itself here, it sounds very interesting. So what will be the method? We are going to shorten the duration and with a least cost. So that will be the area and the consideration we should go for in these methods. Okay, right. So ladies and gentlemen, move on. Okay, so for the comparison, okay, in the very beginnings here, we do have this comparison for AOA and AON. Okay, so I will try to bring your attention over here is about the activity or not. Okay, so activity or not here is about the activities that you can see that in a circle, A is in here. So this is called activity A. But on the activity on error is about, we have one error that connect in between two circles. So that is our here. We only connect this as activity A. Okay. So I hope that you'll be able to see this quite clearly, based on activity A and activity, the AON and AOA difference. Okay, so what I am trying to share with you here, so we have two methods by looking into the diagrams here. So we have AOA and AOA. Now, come for the activity meanings. Okay, so we can say that A come before B, which come before C. So this is saying that A to B, B to C. So we can say from here, A to B, B to C, and your right side is AOA, A to B, B to C. Okay, so that will be about this comparison of networks here. Okay, so let's see about second. Okay, B must be completed, and only C can start. So what is the understanding? Your A and B will be running the program parallelly. Okay, so that makes about the understanding that A and B will come first. Okay, then only C activity will begin. Okay, so that is quite clear about the AON and also the AOA here. Okay, so that's why you can see in this happens accordingly. So how happens to this here? Okay, B and C cannot begin until A is completed. Or in another words here, I can say A start first, B and C start second. Okay, so this is about the sequence that which activity comes first and which activity comes second. Okay, so giving you a quite clear understanding on how we make the comparison from one into another here. Okay, so giving you another further examples here. So we can say that C and D cannot begin until both A, B are completed. So you can say that A and B will be the initial of factors here. Okay, so that's why we can say that A and B will start first. Okay, then only we can go for C and D. So the way they draw this here is that A complete only go for C, B complete only go for C. Okay, same thing to say. A completed only D can continue, B completed only D can continue. Okay, so we have this AON into the picture here. Similarly for our AOA here. Okay, so I hope that you also find for this AOA and AON for D example. Now, how about E example? Okay, E example, I would say C cannot begin until A and B completed. Okay, so we can say that A and B will be at the beginning. Okay, so C will be at last. Okay, but when D come to picture, D cannot begin when B is completed. Okay, so the statement over here is very clear. What do I emphasizing on you on the dummy? Okay, dummy is only in AOA. Okay, so dummy, this dummy, dummy usually we connected with dotted line. Okay, so this dotted line itself here is giving you the understanding when A completed, only we can continue C. Okay, I repeat one more time. So this is dotted line is pointing up. Pointing up to say it's like B completed, only we can continue C. Okay, so at the same time, A completed, we can continue C. So these instructions here is correct. Okay, so meaning to say A and also B completed, only can continue C. So this is also saying that when B completed, only D can continue. Okay, so this is exactly in the activity on error is giving you the meanings here. Okay, so we have AON, we have AOA also. Okay, so these are the two things here you have in mind. Okay, so beyond that here, ladies and gentlemen, we also have another note of the AON here. Okay, so over here we can say that the B and C cannot begin until A completed. So A should start first, only we can go for B, only we can go for C. Okay, but they say D cannot begin until B and C completed. Okay, yes, this is fine here, right? So this part here is quite clearly and very clearly provide you with that understanding for this. So that you're fine with this. Now, moving forward here, giving you the examples. Okay, so a real life examples. So what does it mean by this here? See, if you can see from here, activity A. So sorry, the project itself. Let's see about the project. This is a Milwaukee paper manufacturing. Okay, so this is about the paper manufacturing. So we say that in terms of the factory, they are trying to produce paper. So this is one of it here based on the project. Okay, Now, what we have here for the activity? Activity A, build internal component. Okay. Activity B, modify roof and floor. Activity C, construct collective and stack. Okay. Activity D, pour concrete and install frame. Okay. So I give you some ideas here. Now, you cannot doing your activity itself here. So as whatever the activity you like, because this all here, it will be in a precedence relationship. Meaning to say, it should be in a order here. Which comes first, which comes second. Now, how we are knowing that about those activity, which comes first, which comes second? So therefore, we have this immediate predecessor comes to the pictures here, right? So can you see that? So this is giving that. Now, when we have A and B without immediate predecessor, so A and B itself here, they have no factor before them. That is meant by these two here. Okay. Now, what happened for C activity? Now, C activity say, C activity, construct collection stack. So construct collection stack to say that A is the immediate predecessor. So we are saying that we should build internal component only we have construction collection stack. Okay, so meaning to say A come first, C later. Okay, so our understanding is A come first, C later. Okay, give you one more example. So how about D here? Okay, D is a pour concrete and install frame. Okay, so this pour concrete install frame, they say A and B is the predecessor. So A and B should complete, then only we can start D. Okay, so what is A and B here? We should build internal components, we should modify roof and floor, then only we can start pour concrete and install frame here. Okay, so I hope that you're fine for this, right? So same thing to say. So activity E. Okay, activity E and activity F is here. Build high temperature burner and install pollution control system. Okay, so you see, these two are the different devices or different equipment. Therefore, this is also saying that you completed C, you can continue E. You completed C, you can continue F. So we are saying that after you have construct, collection, stack, then you can build these two. Okay, so E and F will be after activity C. That is meant by these two as the predecessor. Okay. Now, of course, after that here we have activity G. Now, activity G given you the understanding that install air pollution device. But before you install air pollution device, what you need to do? D and E here. So D is pour concrete and install frame. E is build high temperature burner. So you complete these two, you can continue G activities here. That is meant by this here. Okay. F and G will be the factor. H will be the consequences. So F and G should start first. Then only we can start H. H will be inspect and test. It will be at the end here. Getting that? Right. So let's see in the picture. Okay, so you can see this clearly. Now our activity A starts. Okay, so start. We have activity A and B. Activity A is build internal component. Activity B is modify the roof and floor here. Okay, so once we have this here, then the following parts here, we have the B and C. Okay, I say C and D, you can see that, right? So that is about the activity of A precedes activity C. Activity A and B precedes the activity D. So meaning to say that A and B should complete, only we can continue D. So that is mean by this precedes here. Okay, now for further on here, this is all about the network diagram. Okay, so I would say that it's very clearly we have the network diagrams here. Okay, so what is the last activity? Activity H. Okay, so this is a H. What is your first activity? Oh, first is A and also B. Okay, can you see that? A and B start first. Okay, so C, of course, we can say that H, it will be the last, but we have C, D, E, F, G. It's all interconnected. This is all interconnected. This is what we call precedence relationship. Okay, so how about AON? Okay, so AOA itself here is different from AON. Okay, AON is very straightforward, but AOA, we are saying that the line itself here. Okay, so as I mentioned, now for example, A activity is build internal component. Okay, B activity is modify rooftop. Okay, so what is happened for this poor concrete? So this D activity is saying that A should complete. Okay, remember A should complete. Okay, follow my error. Then B complete also, only we can continue D. So in the words that A and B should be completed, only we can start D activity. Okay, so that is what it means here. Now, for your information also, this AON networks here for the Milwaukee project also come with the determining for the project scheduling. Okay, so I will try to explain this together with you. So when we come for the critical path, it's the longest path throughout the network. Okay, so the critical path is also the shortest time. Okay, so why do you say about the longest path and the shortest time? So definitely this come with the meanings here. Any delay for the critical path. Okay, so as we mentioned, the critical path is a formation for all your critical activities. Okay, once we are saying that you delay the project, is also significantly you delay your critical activity duration. So that is meant by the project we are trying to manage. Okay, obviously, we also can see that the critical path activity usually is have no slack time. Okay, I will explain to you what is meant by slack time. Okay. All right. So for your information, okay, so this is about the projects, right? Okay, so of course, in a normal way, okay, I would say in a normal way, so you will do activity A to B, B to C, C to D, D to E, E to F, F to G, G to H. Okay, so this is about the activity you have. So same things here, I would say. You have 2 weeks, 3 weeks, 2 weeks, 4, 4, 3, 5, 2. Okay, so if you try to add up these four, sum of these four here, you are getting 25 weeks. Okay, so I would say it's a very normal path we are going for. Okay, remember that, right? So the total time in weeks we are required to build this Milwaukee projects here is about 25 weeks. Okay, but can we reduce the 25 weeks? Okay, let's see. Okay, gentlemen, ladies, we do have this earlier start, early finish, late start, late finish. Okay, earlier start. What is it? Earlier start saying that the earlier time when the activity can start. Okay, so of course, some of the times here we can say that the earlier start of the activities here we can get it as earlier as start immediately. Okay, so that is also quite true. Okay, now we assuming that all predecessors have been complete. Then what is earliest time we can start the activities? That is under ES. Now, earlier finish. Okay, earlier finish. Okay, earlier time where the activity can be completed. Late finish, latest time at the activity can be started. Okay, late start. So there is no delay. But late finish, okay, for your understanding, late finish is about the time for the activity has to be finished. So there is no delay and the completion time for the entire project. Okay, so this is about the entire things here we do have to perform in the critical path analysis. Okay, so showing you further here on all of these early start, early finish, late start, late finish, that can be presented here. Okay, now I'm showing you about the drawing. Okay, so when the moment we draw here in the circle, so obviously this is referring to the name of the activity. So obviously we're putting A here, so they're saying that this is an A activity. Now, what is the duration for this A activity? 2 or what? 2 weeks here. Okay, so in our project just now, it's all in weeks. So therefore, activity A, 2 weeks here. Okay, now where is the earlier start, earlier finish, late start, late finish? Let's see about the diagram. Okay, so you can say that, okay, earlier start, we have this ES. Okay, so earlier start of the activities. Okay, so if activity A itself, we without predecessors, so we need to say earlier start is 0. So 0 means we can start right now. So when the things here, we start right now, so 0 And this activity is 2 weeks here. So what is the earlier finish we have? 2 weeks also. So therefore, logically, you can say earlier start plus your activity duration. Then you will get the earlier finish here. Okay, can you see that? So 0 plus 2, earlier finish is 2 also. Okay, so that is meant by the earlier finish. Now, we have the late start, late finish here. Okay, so something the same. What is the duration that you have late start? That without any delay. That any of the duration you have for late finish without any delay here. Okay, so that is meant by the late start, late finish here. Okay, let's showing you based on the example. Now, what is meant by the forward pass? Now, forward pass, they say that you can begin the event and work forward here. So we begin the event here and work forwards the same. So we have our activity A, activity B, activity C, activity D. So those activities here is moving forward. So when this is moving forward, you say activity have a single predecessor. The ES, earlier start, equal to the earlier finish. Okay, so very straightforward. I will show you by example later. Okay, now understand the theory also, they think that if we have more than one immediate predecessor, what happens next? So the ES itself here will have maximum value. Okay, so we try to get the maximum value from the earlier start here, based on the earlier finish value. Okay, so that's mean by this ES here, we select the maximum. Okay, so ES itself here is a maximum of the EF of all immediate predecessors. Okay, so that is what we have for the ES here for the next activity. Now, how about the rules, the times rules here? Okay, so the times rules, the first one. Okay, first one is say earlier finish of the activity, it should be the sum of the earlier start of the activities. So therefore, we have this here to be saying that EF equal to ES plus activity time. Okay, so the formula is being given for you. Okay, so therefore, we have this formula to be in picture. Okay, now let's see here, right, for the following. Now, of course, for your understandings here, I will demonstrate to you on how this works. Okay, now, if you're looking for activity A, okay, so activity A, where is our predecessor? The predecessor is start. Okay, so 0 plus 0, how many? 0. So this 0 will be bring forward to our activity A here. So when activity A with the earlier start 0, we plus activity duration 2, then we will get earlier finish 2. Okay, right? So far so good. Now, so looking for activity B, now our earlier start is 0, 0 plus 3. So our earlier finish is 3. So far so good. Okay, right? So I go for activity C. Okay, now, so our C here, as I mentioned, this activity with one predecessor. Okay, so activity C is from A. Okay, so A with earlier finish 2, these 2 will be bring forward to here as 3. So when 3 plus 2, you get 4. Okay, so that shouldn't be any problems. Now, when you come from activity D, this one you need to pay attention. Okay, now activity D itself here, we have how many predecessors? We have 2 predecessors. Okay, where is the 2 predecessors? A activity and also B activity. Okay, so you see, A activity earlier start is, earlier finish is 2, but the B activity earlier finish is 3. So why you select 3? Why not you select 2? Okay, so we try to understand. Now, if you select 3 itself here to say 3 weeks activity D only can start, is that true? Okay, we think carefully. Now, in activity A, in how many weeks you can finish the activity? 2 weeks here. Yes, very good, very short time, 2 weeks here. But do remember, the activity B, it requires 3 weeks. Okay, so in 2 or 3 weeks, we try to go. We have to think carefully. Now, in order to start the activity, the relation saying that your A activity must complete. Your B activity must complete. Only you can start activity D. So if we choose number two here from this, by right, your activity B are not yet finished. Okay, so therefore this should not be number two. It should be 3 weeks here. So in your 3 weeks itself, we say your activity B finished, your activity A already finished 2 weeks, 1 week ago. Okay, so therefore you only can start activity B here. Okay, so therefore in this calculation, it also same with the activity G. Okay, I show one more time. Let's see. Activity G, how many predecessors? We have E, you have also D. Okay, so how I know is E and D? Now the error. So the error pointing E activity, the error pointing D activity. Now, so we have the earlier finish, which is 8 for activity E, which is 7 for activity D. So which one we should go? Definitely is 8. Okay. Why is go for 8? Because by 8 weeks, your activity D already completed, your activity E also completed. So therefore, G can start at activity in week 8. 8 plus 5, which is 13. Okay. So overall for this year, what I can provide for you with the understanding to say, when we are moving from left to right, we always apply plus. Okay, so plus means here you add numbers and also you select the maximum. Okay, how do I say select the maximum? Now, in between 2 and 3, which one is the maximum? Maximum is 3. 3 will be your answer. Okay, same thing here. 7 and 8, which one is the maximum? 8. 8 will be your answer here. Okay, so how about the H? H, how many predecessors? F, F, and also G. Okay, so we have 13 here, we have 7 here. So which one you should select? 13 here. Okay, so therefore once you're selecting this here, you will get, okay, remember, you will get the 15 as your answer. So what is this 15 for you? Okay, so 15 by right. Now, if you still remember, in the original, all the activities here, when we add on, that should be in 25 weeks. Okay, I show you actually. I show you previously, right? If you still can remember, yes, this one. Now, if you still remember, I have guided you just now. All the activity we plus here, we are getting 25. Okay, 25 weeks here. So when this is in 25 weeks, as compared to the scheduling we have just now. Okay, so you see, now it's 15 weeks here. How many weeks we can reduce? 10 weeks we can reduce. Say, is it good or not? This is a very good method. CPM, plan analysis, is a fantastic method. Okay, so this method allows us to have the projects here to be shortened, and we can arrange whatever our resources here to be catered for this project itself here. Okay, so allow me to move on. Now for the backward pass. All right. So the backward pass here is given you the understanding we should following the rules. Now, if activity is an immediate predecessors for just a single activity, the LF, the late finish, equal to the late start. Okay, so that is also allowing that if the activity itself here with the immediate predecessor more than one. Okay, so with more than one here, our LF will have the minimum of all LS value of the activity, then with immediate following it. Okay, so the formula given here. Okay, so you can see our formula given here. LF minimum, LF, LS for all immediate following activities. This is all given. But I'm more looking for a practical use, right? So you can see this carefully here. Now the times of rules here. Now what is it by the times of rule? The late start time, LS. The activities is different from the late finish time of the activities. Okay, so in the words that we can say that we can following about the rules here. Okay, you can see the rules is here. Late start equal to late finish minus activity times here. So that is what we mean by the formula given to you. So when this formula given to you, what is the next things here? Okay, so we're looking for the late start and late finish projects here. Okay, So what you can say now, if I have the 15 duration for my late finish, this is also the same with earlier finish here. Okay, so these two here by right is a 15 and 15 here. So this only apply for the last activity in my duration. Okay, right? So this cannot be applied for F, cannot be applied for G, cannot be applied for any of the activities here before H. Okay, because H is the last activity. Okay, now of course I will say the rule of thumbs, the rule of thumbs. Okay, how are we getting 13 here? Now see, late finish equal to late start. Okay, this is the late start. Late start equal to late finish minus the activity time. So where is the activity time here? 2. So 15 minus 2, you get 13. Can you see it? Now we are going backward. Just now we are going forward. Okay, so if forward we are applying plus and choose the maximum number. Backward, now we are select the minus and minimum number. Okay, so I show you the examples here. Okay, so we have all the answers. Okay, how do I say all the answers there? So you can see that based on the activity H30. Okay, so this 30 will go for G30. We'll go for F13 also. Okay, so how we calculate? 13 minus 3, you get 10. Okay, so same thing to say. 13 minus 5, you get 8. Okay, so I think it's quite clear, right, on this side, the bottom part. So we move backward, we minus. Okay, so once we minus here, then the next thing is 3. Now, based on our predecessors, okay, so this will be getting 8. Now, 8 will be looking into E as 8 and also D as 8 here. Okay, 8 minus 4 is 4. 8 minus 4 is 4. Okay, I think that is fine here. Okay, so how about C? C, we have 10. We have 4. Which one we choose? Remember, right? So this is a minimum we should choose. Okay, we choose number 4 here. So number 4 minus 2, you get number 2. Okay, so why the 2 in here? Why not we take number 4 in here? Can you see? 2 and the 4. Okay, so why not we take 2? Sorry, why not we take 4? Why we take 2? Okay, simple, because 2 is the shortest. Okay, so we want to shorten the duration. We shortest these exactly the time here. Okay, so therefore 2 minus 2 equal to 0, 4 minus 3 equal to 1. Okay, so what is the next thing here? Okay, let's see. Right. Now, we do have a slack time. Okay, so just now I have briefed you earlier. Slack time is an important exercise for us to identify the critical activities here. Okay, so see, they say after computing the ES and EF, LS and LF, we have done the earlier start, earlier finish, late start, late finish for all activities. So the next things here, we are trying to compute slack time. Now, slack time is saying that about the free time for the activities. Okay, so of course, how we calculate the slack time? Slack time is the length for the times of activity can be delayed or without delay. Okay, so that is meant by the slack time. Okay, so therefore, in the slack times here, we have the formulas: late start minus earlier start, late finish minus earlier finish. Okay, so that's meant by the formula. So we are applying either way or. Why or? Because you will get the same answer. Okay, how do I say? Let's see. Okay, right. So for example, I put into number 1, activity A. Earlier start is 0. Earlier finish is 2. Okay, right. So how we get the slack time? Right. So we have to get the start, the earlier start, and the late start. Okay. So when 2 minus 2, there you go, is 0. Same things here. When the late start and the earlier start. Okay. Start 0 minus 0, also 0. So therefore you get slack time is 0 here. Okay, I give you one example, activity F. Now, activity F itself here, we have earlier start is 4, correct? Right, earlier start is 4. Late start is 10. Okay, so 10 minus 4. How much? 6. Okay, same things here. Late finish, 13. You see, right? So earlier finish, 7. 13 minus 7, also 6. So therefore, I would say your late finish minus early finish is the same answer with late start minus earlier start. Okay, so obviously that will be the both part here we have. Okay, right. So I hope that you understand this part. Now, in order for you to know which is the critical activities, okay, how you know that? Which activity here is critical? Critical means important, right? So when a critical activity is here, usually we say the slack time equal to 0. Why? Because this activity we cannot delay. So this is very important activity here. So 0 for A, for C, for E, for G, for H. So that's why we have to say yes, 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 yes. All the yes is for critical activities. So if we connect that, that is what we call critical path. Okay, remember, right? So let's look into critical path for the Milwaukee projects here. So this is one of the Milwaukee projects here. We have activity A, then we continue for activity C. After activity C, we continue for activity E. Okay, activity E continue for G, G continue for H. So that is about the longest path in the network. And this is also the critical path, okay, that connected all critical activities. How many critical activities we have? 5. A, C, E, G, and also H. Okay, so these are the 5 activities. Now, I did mention to you, when we have 5 critical activities in here, where is the non-critical activities? That will be activity F. That will be activity D. Activity B. Right? So these 3 activities here, they are not critical activities. Okay. Right. Okay. So if we try to calculate the slack times, so we can say slack time for activity B is 1. Slack time for activity D is 1. Slack time for activity F is 6. Okay. So that those activity which is not equal to 0, they are non-critical activities. Okay. So activity with slack time equal to 0, they are the critical activities. Critical path is about the critical activities that join from the start until the end. So therefore, we have activity A, C, E, G, and H here. So this is a critical path we have based on all the slack time equal to 0. Okay. Okay. So how about the AOA network? Okay, so I'll show you the details of AOA networks. So you have all the AOA networks here, right? So AOA network itself here, we have activity A, B that we modify until the activity we complete all this here in very details. Okay, so all the networks here is in details here. I'm providing you about the information accordingly here. So I would say that is fine for these activities. Okay, so variability for the activity. Okay, ladies and gentlemen. Okay, so I will present to you about the variabilities here. Now, in CPM, we assume that the time is fixed. Okay, for example, activity A, 2 weeks. Activity H, 4 weeks. Activity B, 3 weeks. Okay, so that is about the fixed activity. We don't have any of the variability for the activity duration. Okay, so very clearly, we have activity A to build that estimated in 2 weeks. We have activity B about the arriving material that will take about 3 weeks here. Okay, so PERT analysis, yes, we allow. CPM not allowed, PERT analysis allowed. So when PERT analysis comes towards the pictures, they are more looking for the probability or the distribution that is allowed. The timing will be slightly different. Okay, so that is what we mean by the PERT analysis. Okay, so PERT analysis here we do have about these three estimated as required: optimistic time, pessimistic time, most likely time. So what is the difference between these three? Okay, so if you say that, okay, so most likely time, I'm looking for the answers there. Now, most likely time is about the activity, for example, activity A in 2 weeks here. So most likely time, we say this is a realistic. It really can happen. Okay, that's why we put it M. Okay, so most likely time. Okay, so when we have pessimistic and also optimistic, the main difference here is now optimistic. Sometimes we say, okay, 2 weeks. Sometimes I can say I can finish the project in 1 week. Okay, pessimistic. So you think very pessimistic. Okay, so you think that this everything is accordingly to the plans here. Yes, the times of duration can be reduced. Okay, so that will be the difference of the opposite from the pessimistic times, right? Optimistic times here is saying that everything according to, but pessimistic times here, we assume that the condition slightly will change or will take longer time. Okay, so pessimistic say we can say now in terms of activity A for 2 weeks, we can say pessimistic times here probably 4 weeks. Okay, so therefore we have pessimistic time to take longer time than the others here. Okay, right, that is what we have here. Okay, PERT analysis for you, right? So PERT analysis here we have formula. Now formula given. Okay, so T equal to bracket 4 plus A plus 4M plus B divided by 6. Okay, variances of times here equal to B minus 4 divided by 6 square root. Okay, so this given you about the formula. Formula definitely will be provided. Okay, shouldn't be any problems. You can say, right? Okay, so what does it mean by this here? Normal distribution. You can see a better distribution. You can say this is a bell curve. Now, most likely here usually will be the center. Okay, most likely. But we do have optimistic. We do have the pessimistic here. Okay, so we have that in our distribution for data just now. Okay, now in computing variance, okay, you can see that over the scene now is very clearly. Okay, so these computings here we do have the variances that take place for optimistic, most likely, pessimistic. We have applied the formula for expected time. We also applying the variances expected. The variances here. So once you have all of the computations, therefore you will get all the answer based on the formulas here. Okay, so for example, okay, I show you based on the question. The activity A here. Okay, A is 1. M is most likely. Okay, A is 1. M, they say 4M. 4 times 2 is 8. 1 plus 8 is 9. 9 plus 3, how much? 12. 12 divided by 6, number 2. Okay, so from here, you can see all of this here, if you run by formula, you will get the answer. Now, similarly, you also can get the answer for variance. Now, I will ask you, when the moment you get the answer, what is the answer means to you? Okay, so let's see. Now, probability of the project completion, we do have the project variance. Okay, so in the project variance, then we can get the sum of all the variances for activity on the critical path. So remember, we are only looking for activities on critical path. In other words, we can say we are concerned with the critical activities with the variances. Okay, so that is meant by the project variances. Okay, let's see about this here. Okay, now we have how many activities here? We have activity A, okay, activity C, okay, activity E, G, and H here. Okay, so C, A, C, E, G, and H. Okay, so where you get this all this number? So all this number is from here. A, C, E, G, and also H. So therefore, if you try to add all the project variance here, is about all this activity on the critical path, we will get about 3.11. Okay, the project variance is 3.11. What is that mean? Okay, it's about the variance, but we should get the standard deviation. Okay, so to get standard deviation, we refer for these formulas here, right? So standard deviation is about the square root of your project variance. Okay, so what is happening to here is V square root of 3.11. We get 1.76 weeks here. And what is meant by this 1.76 weeks? I will have the answer for you. Okay, right? So this 1.76 weeks here, we can say that there is a plus minus for the project here, can be delayed or can be earlier. 1.76 weeks here. Okay, so probability itself, we have some assumptions. Okay, so we are assumed that the completion time for the project is following the normal distribution probability. Okay, second is here, we are saying that activity time are statistically independent. Thirdly, we are saying that the bell curve, okay, the bell curve, it should be very smooth. Okay, so to represent the completion for the project and also the date accordingly. Okay, so therefore, when the moment we draw the bell curve, you can see from here, nicely done. Okay, so standard deviation 1.76. Okay, how many weeks? Based on the 15 is the optimal weeks here. Okay, so what is really mean by this here? So standard deviation is about the quantity that express how much a member differ from the mean of the value. Okay, so that's why we have the 1.76 here. So 1.76 here, I'll show you in the next slide. Now, probability to complete the project here. How do you think about the probability? Okay, the probability, the percentage to complete before the 16 weeks here. Okay, so you know the completion optimum is 15 weeks. Okay, so we are saying that the due date is 16 weeks. The expected time we can complete is 15 weeks here. But what is our standard deviation here, right? So the project variance, the standard deviation. So the standard deviation is 1.76. So we apply this formula, here we get 0.57. So is it 0.57 says about 57 of this probability for the project to be complete before or on the 16 weeks? No. Okay, so this is a Z value here. So Z value itself, we should refer to the table of standard deviation. Okay, so therefore, I'm saying to you that when this comes from the appendix here, so in your reference later, you do have this 0.57. Okay, how we get 0.57? Let's see, 0.5 we refer to here, 0.5. So in this 0.5 itself here, we have another is based on 0.57. Okay, so you can see 0.07. So this is about 0.71566. So this value given you the understanding, I write the project fully complete in 71.5% if the project be given deadline 16 weeks here. Okay, get it? Right. There will be the answer we have here. Right, exactly 71.566 here. Okay, so we are referring this is for 0.5. We are referring this for 0.07. Therefore, this is about the 0.57 here. Okay. Always from your left side, 0.5 plus. Then only you see 0.07. Okay, right. So this given you about the understanding for this year, including standard deviation is 0.57, correct? This is the standard deviation. Okay, so from 15 weeks to 16 weeks here, if they given about 16 weeks here, okay, what is your probability? So the probability given here to say there is about 71.57 probability this can be completed. That is what is meant here. Okay, So this standard deviations here also given you about this probability. Okay, so if you try to determine the completion time, it's about 0.99. Okay, so 0.9 time is saying that it's almost this project here can be completed on time. Okay, so that's why we have the high probability of 0.99. 99% of the projects here can be complete on time. Okay, so this is the formula we are determined here in order to get the time that how we can get about the 99% of the completion time to be on time. So the formula we apply here, expected time plus 2.33 times 1.76. 1.76 is the standard deviation. Okay, so once you have complete all the exercise here, you will get 19.1 weeks. So meaning to say, in complete this project, 99%, merely to say that this project can be completed. We need 19.1 week. Okay, so that 19.1 week become just for you. Okay, so variability for this time for the activities here is all based on the critical path. Okay, so I mean based on the activity on non-critical path to be considered. Okay, so we also mentioned that the variation on the non-critical activities may cause some changes in path. So that's why we say that the variability here is focusing on the non-critical activities in your network. Okay, right. So some summary for you. Okay, so if you try to recall, so based on the same project we are talking about here. Now, first and foremost, you have the project here expected to be on 15 weeks. Okay, so that's why you get the last activity and the earlier finish. You get 15 weeks here. Okay, so the 15 weeks here is here. Right. So this project here is using 16-week deadline. Okay, so if 16-week deadline, your project can be complete in 71.57 with all equipment, with all resources, with everything resources that you have here. Okay, 71.57%, the project can be complete in 16 weeks. Okay, so how many activities are on critical path? You have 5. A, C, E, G, H. Okay, so meaning to say, if you delay for the activity on critical path, you are delaying the entire project. So that is meant by this 5 activity on the critical path. So we have 3 activities for you. Okay, so they are not on critical path. So therefore, we name this as a non-critical activities. So when due to non-critical activities, so this also saying that the resources, it might be borrowed, the activities here is not so important to affect the speed up the entire project durations. Okay, so what also you learned from the project management so far, that is also about the time that you spend. Okay, so starting, the end date, the select time, the critical path, the activities here, whatever the activities here regarding your precedence relationship is all in the network can be performed here. So therefore, we have this here for your pictures. Okay, right. So looking at this here, trade-off and project crashing. Okay, so I would say trade-off and project crashing, giving you the understanding that the project is behind the time. Okay, so of course, for talking about here, the behind the times here, we say certain of the projects here is we need to finish the activity by week 10. Okay, but finish behind the time, behind the schedule to say, by the activity itself here, we have passed more than the time required. So that's mean by project is behind the schedule. Okay, so the completion time has been moved forward here. So sometimes here we can say that the completion time move forward to say we might need the time required in a shortened way to finish the products. Okay, so giving you the understanding for this here, say shorten the durations for the project is called project crashing. Okay, so obviously this part here given you any of the project itself, it will have the least additional cost. Okay, so any of the project crashing, it will involve cost. So the way we are looking forward this year is try to use the least additional cost for the project crashing. Okay, now factor to be considered. Okay, first, the amount of each activity is crashed. Okay, so we always saying that there is a passive moves. Passive mode activities here, we try to have these projects here to complete, right? So we also tackle on all the activity or the shorten the duration for the projects here is all due by the due date. Okay, the cost for the crashings here is also, if possible, as small as better. Okay, so the total cost crashing to say when we try to reduce from 15 weeks into 14 weeks, we reduce 1 week. Okay, so that reduce of 1 week here, usually it will involve cost, additional cost period. Okay, so that's why we have that to the pictures here. Okay, so this total crash cost to be minimum. Okay, so this is about the step-by-step in project crashing. Okay, now first and foremost, we do have project crashing is for the crash cost per time. Okay, so this crash cost per time, we're running the formula. The crash cost minus normal cost, the normal time minus the crash time. We need to divide it. Okay, so that's mean by this formula here, crash cost per period. So moving forward here, we have the using current activity times. Okay, so this is the current activity time. We find the critical path and identify the critical activities here. So we have to follow by using this accordingly. Okay, shouldn't we have any problems here? We are trying to do this as once. Now, beyond that, we also have the numbers of the others here, including. Okay. Sorry. Now, the other things here, we are saying that we try to use the activity time, find the critical activity path, and identify the critical path. So how we do that? Okay, I'll show you examples for that. Okay, now step in the project crashing. Now always think of, okay, so 2 criteria. Okay, so we are trying to get the project itself here, they must be able to crash. To crash to say, we'll be able to know the activities here can be reduced the duration. Second is here, we try to select the activity with the smaller crash cost per period. Okay, so if we are unable to get that by right itself here, we can reselect the activity to crash again. We can recalculate the total crash cost, okay, for the activity which is the smallest. Remember, now for project crashing, as I mentioned to you, we are trying to shorten the duration. Okay, so is it correct that when the moment we try to shorten the duration, we have to select the critical path, which means the critical activities is the activity you should focus, that the activity should be selected. Okay, so note that the same activities that may be common for more than one critical path. Okay, for your understanding, so we go step by step. Now the number 4 step. Okay, number 4 step say we update all the activities. Okay, so sometimes here we have done about the first activity. I mean the first step, the second step, the third step. Now the 4th step here we update. Okay, so you update all the activity times. So based on the times that you are reaching, for if reaching, you are fine. So if you are not reached, you should return to step 2. Okay, so you do it again. Okay, in the step 2, what we have? So this is step 2. So we're using the current activities, we find the critical path, we try to identify the critical activities, then we continue the step 3 again. Okay, so identify the activity can be crashed, get the smallest crash cost per period. So that is mean by this number 3 steps here, right? Until you are reaching the due date that you want. Okay, so what you mean by the due date that you want? Okay, for example, we have 15 weeks here. So 15 weeks here, if you wish to have the duration shortened by 2 weeks here. So we're doing the activity repeating until you get activity to be complete in 13 weeks. That is mean by project crashing here. Okay, right. So this is about the project crashing we have for the critical path. We have A, C, F, G, E, D, B, H. Okay, so all the activities here, they have the activity that represent, okay, after the project crashing here, right? Now, so let's going on for the next here, right? Crashing activity, this is about the summary for you, okay? So how we are getting the crash cost per week, ladies and gentlemen, can you see, right? So crash cost per week is about our crash cost minus normal cost divided by normal time minus crash time. Okay, so therefore you can say that 22750 minus 22,000, you will be getting about 750. 750 divided by 1, 2 minus 1 is 1. Therefore, you get 750 cost per week. So what is mean by this here? Okay, so by right, I should giving you the understanding. Okay, so saying that crash cost per week here is mentioned in a week time. If we crash activity A, we need to pay 750. Okay, right? So I hope that you're fine for this, huh? Right? So in other words here, if you see this carefully, if you see this carefully here, so we only select activity which is under critical path. So we are only select critical activities here. So where is our critical activities? 750, so activity A, activity C, activity E, activity G, and activity H. Okay, so I ask you one question. Now, based on these 5 activities, which activity are having lower cost? Okay, some of you might say, okay, 500. Yes, 500 is a lower cost, but this is not under critical path. Okay, so we not consider this. Okay, this is wrong. Huh? We not consider this, but we're going for the other activities here. As such, activity A, activity C, activity E, activity G and H. Okay, so we have 750, we have 1,000, we have 1,000 here, we have G, 1,005, and 3,000 for activity H. So what you supposed to do here? Very simple. Now among these 5 activities, which one is the lowest? 750. So when crash cost, for example, 15 weeks, we crash into 14 weeks. So which activity you should select? Activity 750, which is activity A. Okay, why activity A? Because 750 is the lowest of crash cost per week compared to activity C, 1,000, activity E, 1,000, activity G, 1,005, activity H, 3,000. Okay, so that will make the difference in between these. Okay, so the crash cost per project here, that will be given the summary of 50 weeks. We crash 1 week to become 40 weeks. Company need to pay $750 for this 1 week works here. Okay, right. So I hope that you're fine with this, huh? Right. So the crash and the normal time and the cost for activity times here. So we have the crash and the normal times here. So we have this 34,000 crash cost. Okay, so we have the normal cost is 30. So 34 minus 30, then we divide by 3 minus 1. That is how we are getting the entire duration for this here, for the crash cost per unit here. Okay, so I hope that you're fine with this. Right, so a given example for this. So what is meant by the 2,000? 2,000, remember, this 2,000 is by 1 week. Okay, 1 week for activity B. Therefore, there is given about the 1 week to cost you about 2,000 here. Okay, then I ask you one simple question, sir. In activity B, how many weeks you can crash? Okay, I repeat that. In activity B, how many weeks you can crash? Okay, so you see carefully, sir. So 3 minus 1 is 2 weeks here. So meaning to say, there is potential for you to crash 2 weeks. Each week itself here is 2,000. So therefore, you can see this carefully, sir. Your total crash cost for 2 weeks here is 4,000. But if you divide by 2 weeks, 1 week itself is 2,000. Okay, right? So that will be the summary for the crash cost for activity B here. Okay, so it's another example I show to you. advantage. I given the advantage here for the CPM and put analysis for you. So the advantage here including we will know about the scheduling, okay, control the large projects here. So we also will be very straightforward for the concept, are not mathematically complex. So you won't have a very complex of formulas here. You need to remember, right? So in managing the CPM and also put analysis is quite simple. Okay, it's just about sometimes we have to be very careful. Okay, so in determining which projects here we try to crash. Okay, so that will be more cautioned in terms of your preparations. Thirdly, we have the network. Graphic network will help you to know which start first, which start second. Okay, so if you're looking for the activities here by the table itself here, sometimes it will given you about all the activities here is quite not easy to see. But if we have a network, okay, so the entire of the networks here, you can see the things here very clearly. Okay, so the information provided for you, including we have the critical path, we have the slack time, we have the non-critical activities, we have the critical activity to be concerned, and numbers of that here also become the advantage for you in this CPM and put analysis here. Okay, so without further ado here, we also have the project documentation and graphic. Okay, so numbers of that here, I mean, what are the projects here, what are the analysis for the activities here, it should be referred to which are the responsibles activity and who will be responsible for it. So that we also can schedule in our project. Now, applicable for the wide variety for the projects here, we're saying that this kind of the arrangement, the scheduling, as mentioned, we can apply for most of the project. Okay, rocket science, the project of building cars, building condominiums, building bridge, buildings constructions, okay, building a school or whatsoever here is definitely possible and applicable. Okay, so very useful, not just because of the time we are controlling, okay, but in terms of the budget, in terms of the allocation of the works here, that from one into another's of the predecessor relationship is marvelous for this advantage or the benefit enjoyed if you're using the PERT and the CPM in scheduling your project constructions here, right? Okay, but when every project, it will have the limitation. Now, limitation comes to you to say, okay, each of the activity here have to be defined. It have to be closely monitored. It have to be predetermined in your relationships here. Okay, so that's why we have this here limitation of the PERT comes to us as a picture here. Sorry. Okay, second issue, the precedence relationship must be specific. Okay, so you have to identify which other activity start first, which activity start second, which activity can be parallelly start. Okay, so that is meant by the precedent relationship must be specified. Okay, thirdly, we do have the limitations that is talking about the estimate time is very subjective. Okay, especially here when the moment some of the estimated time by manager is not realistic. Okay, so because it's subjective here, one manager saying about 7 weeks, second manager saying about 8 weeks. So which one we should follow? So that's why we say the limitation for this is purely based on the subjective to the fudging. That is what we call FANG by the manager. Besides that, okay, so there is numbers of the other things here we are not taking into consideration. For example, the changing of environments. Okay, so the delay for the projects here, what is the action plan? We try to recover that. That is all we are not considered here. So even there is a good approach by the PERT and the CPM analysis, no matter how, there is some difficulties and challenges faced. So therefore, we might need this PERT and CPMs here to be in pictures. Okay, right. So gentlemen, ladies, we are coming to the end here. So this project control report here comes together with the breakdowns for each of the tasks. The labels for the curves here, we might need to know, especially the bell curve. Okay, distribution for the cost here, for the tables here, we will require function for the hours, the cost, the raw materials, the variance of reports, the total estimate of reports, work status here, all of this here, we can provide a summary. Okay, and we can provide and show it into a report forms. Hence, this is one of the good things here we'll be able to get from the PERT and CPM analysis. Okay, so without further ado, I will say about the Gantt chart. Okay, so Gantt chart for you, so we do have available for the loading and the schedule for the Gantt chart. I'm showing the example for you on how is the Gantt chart looks like. Huh? So you can see from here, a simple Gantt chart is happen something like this here. Okay, so you can see activity design is have 1, 2, 3, 4, 5, 6. Okay, so we have 6 timings here for the design. But within the design duration, your prototype is already here. Okay, already started. Okay, your test is slightly late start from your prototypes. Okay, so we can say that during your design, your prototypes and your test is already completed. Okay, revise is slightly because revise you need more times here, and production will be start right after. Okay, right after your test has been completed here. So production will be ongoing until the end here. So a very simple schedule chart for the Gantt chart be able to assist you further on how you are seeing the pre-season relationship in a clear pictures. Okay, so this clear pictures here is giving you about the overall for what you have here. Okay, so if you are using Microsoft project, okay, so a Microsoft application, they do have the projects here that provide to you on the activities that you are keying in. Okay, so you key in all the data to be able to get this project to be scheduled at one another here. So the good thing under the Microsoft projects here is giving you the understanding the project itself or the activity itself. It can be behind the timelines, on the timelines, or otherwise. Okay, so that can be monitored much more easily. Okay, so that's why we say that in Microsoft project itself, if we're looking for a simple Gantt chart, Excel file can help you. If you're using a quite software to do it, Microsoft project can do it. Is that only Microsoft project? No, we have others. Okay, so let's see from others. So for the project management software, we have Primavera, we have Back Project, we have Taskmaster, we have BC Schedule, Timeline, definitely most popular here, Microsoft Project. So all of these popular packages here is help you to manage your project. Okay, some of the project lines are mix we have right now here is also available for you to do it online. Okay, so that is about the projects here. Okay, gentlemen, ladies. Okay, so welcome to these sessions here. So I have completed. Okay, so as the overall for what we have for the project management. Okay, so this is one of the managing project lessons giving you about the numbers of understanding from one into another here to managing the project entirely. Okay, so perhaps here I will try to schedule about what we have for you. Thank you so much. Okay, right. So perhaps here I provide some summary for you. Okay, I think that is much more easier. Okay, so summary, I start from here, right? Okay, so this summary itself here, we have managing some of the projects. So some of the project come towards the picture. In planning, we have planning the project, to identify the project, to know the breakdowns, right? So we have do the example for the project, right? So we also have the purpose, okay, why we are doing a scheduling for the projects. Okay, we have this here. So the techniques I have shown you just now, the Gantt chart, the CPM, the analysis, there is all in pictures, right? So other than that, here we have the 6 steps, okay, very important steps for you to undergo for this analysis. Okay, so marvelously, you are also knowing about these 6 steps here. So then step number 5, very important, compute the longest time path throughout the network is what we call critical path. Right. So other than that, here we have numbers of comparison. Okay, so we have AOA, AON. So we have showing you some of the examples here, right? Okay, so importantly here is about how we draw the AON, okay, how we draw the AOA. Now, to determine here, you can see clearly. Now, of course, if you try to complete the activity from A to B, B to C, C to D, D to E, E to F, F to G, G to H, it will take you 25 weeks. Okay, so if we apply a diagram here, so this diagram here will be giving you about 15 weeks here. Okay, all the activity completed, we can reduce 10 weeks. Is that better? Definitely. Okay, so we are saying that about using this PERT and CPM analysis, we can have a better comprehensive summary here. So we are getting this here, 15 weeks here. Okay, so that will be better. We are knowing that which is the critical activities, which is a non-critical activities. Okay, recap for you. Critical activities is about the activity start with 0. Okay, so emphasize again. So from here we have activity A, C, E, G, and H belongs to the critical activities. Okay, so at the same time, I would also emphasize we have 3 non-critical activities. We have activity B, select time is 1. Activity D, select time is 1. Activity F, select time is 3. So therefore, that is about the critical activity and non-critical activities. Okay, so you know about the distribution. You know how to compute the variances. Okay, by using the formula, we can get the expected time and also the variances happen. Right. So right after that, here we also knowing about the total of probability for the project to be complete here. So that can be in the pictures. Right. Okay. Other than that, here we have the factor to be considered in project crashing. Okay. So we have also the step to be involved in project crashing. We have total 4 steps here. So step 1, 2, 3, 4. It will be repeated, okay, until you get the time that you need here. Okay, so for examples here, so like just now, okay, showing you about this project here. Okay, so project crashing here is always we should select based on the activity on the critical path. Remember, activity on the critical path. Okay, we have 5 critical paths here. So therefore, we have A, C, D, G, and H. Okay, so you try to determine which critical activity that on the critical path will have the lowest cost per period. Okay, so obviously we can say that the activity, sorry, oops. Okay. So the activity A, okay, your activity A itself is better because activity A here gives us 750. That is the lowest path. I'm sorry, lowest cost per period here. So that is what you need to be included in this 750 here. Okay, right. So besides that here, we also have the others here like Gantt chart. Okay, a simple Gantt chart. Okay, so based on the simple Gantt chart, we get about the Gantt chart in specific durations here. Okay, so we have a Microsoft project. Okay, so to get you about all to draw the Gantt chart. Okay, so the Gantt chart here, you can say that is quite clearly they are determined. Okay, so we also knowing that what are the activity can be completed earlier or completed on time or complete is delay here. So we're also knowing about all the activities that are indicated the time and the duration accordingly. Okay, so therefore, ladies and gentlemen, we are reached to the end. Okay, so I'm very happy to see you. Right, so see you again in the coming day here. Okay, thank you so much.